Hello and welcome to our next video covering material from section 4.3 of our calculus text. And in these next two videos we're going to be looking at five functions and applying the first derivative test to them to not only classify where the functions have local max and local min values, what those values are, but also identify the intervals on which the functions are increasing and decreasing. So what we're going to do here, as I've just said, is we're going to identify the intervals on which these functions are increasing and decreasing, and classify critical points as local max or local min using the first derivative test. So just a reminder, the first derivative test once again says that if the derivative of a function switches from positive to negative at a critical point, then the function has a local max at that critical point, and if the derivative switches from negative to positive at a critical point, then that function has a local min at that point. So our first example is going to be to look at y equals 6x cubed plus 18x squared. So our first step is going to be to find the critical points, and that will be the case in all of these examples. So y prime is equal to 18x squared plus 36x. So find the critical points. So I'll set y prime equal to 0 here. This function is not undefined in any place. I can factor out an 18x. And so that's going to lead to x equals 0 and x equals -2. So these are my critical points. And so I'm going to talk through what I do. I'm not going to write down what my process is going to be here. But what I'm going to do is I'm going to create a number line. And I'm going to plot the critical points on that number line. And I want to make sure I get them in the right order. And what I've done then is I've divided the number line up into three intervals in this case. And if these the places, if -2 and 0 are the only places where the derivative is equal to 0, then what must be the case is that on these three intervals, for numbers less than -2, for numbers between 2 and 0, and for numbers bigger than 0, the derivative will not change sign within, I guess is what I should say, within these intervals. So if I can figure out the sign of the derivative at one point on the interval, that will allow me to tell what the sign of the derivative is at all points on that interval. So let me erase that. Get my -2 back up here. So what I'm going to do then is I'm going to just pick a single point on each interval. And so I'm going to call these test points. And so I'm going to pick a test point on each interval. For the numbers less than -2, -3 is a really good choice. For numbers between -2 and 0, -1 is a nice choice. And for numbers bigger than 0, I'll let 1. And let me change the color on these so that we're not confusing the test points with the critical points. So my test points are -3, -1, and 1. And so what I'm going to do next is I'm going to find the sign of f prime. at each of these points. And so I need to do some calculation. And it's going to be important for you when you're writing things up to show your work. And so we don't have to go into gross detail, but we do want to be a little bit careful. So I'm going to use this formulation for f prime to help me. And so f prime is going to be 18 times negative 3 times negative 3 plus 2. Negative 3 plus 2 is negative 1. And then I don't have to really care about the value, but I do see that I've got a positive times a negative, and that's going to be a positive number. At negative 1, I'm going to get 18 times negative 1 times 1. And again, now here I've got positive times negative times positive. And let me change that to positive here. And so positive times positive is a negative number. And then f of 1 is going to be 18 times 1 times 3. And those are 3 positive numbers. So the product is positive. So far I've found test points and I've calculated the sign of the derivative of each of those test points. And the next thing I'm going to do is I'm going to talk about the behavior of f. Well, if the derivative is positive, that means that the function is increasing here. If the derivative is negative on this interval, it's decreasing. And if the derivative is positive, that means that this function is increasing on this interval. So what I've done is I've identified the behavior of the function on each of these 3 intervals. And then finally, if I'm going from increasing to decreasing, that must mean that this is a local max here at 2. And if I'm going from decreasing to increasing here, that means that I've got a local minimum here at 0. So I can summarize my results. F is increasing on the intervals from minus infinity to negative 2 and from 0 to infinity. F is decreasing on negative 2 to 0. And f of negative 2, which if we plug in, sorry, not doing the right thing there. F of negative 2 is going to be 6 times negative 2 cubed plus 18 times 2 squared. If you do the arithmetic, I believe that turns out to be 24. This is a local max value. And f of 0, and that's pretty clearly 0, is a local min. So I've followed my instructions here. I've identified the intervals on which the function is increasing and decreasing, and I've classified all the critical points as either local maxes or local mins using the first derivative test. That's my first example. Got a few more. Y equals 2x e to the negative 1/4 x is my next example. So I'm going to follow the same procedure, find the critical points, figure out my interval, find test points, evaluate the derivative at those test points, classify my intervals as increasing or decreasing for the function f, and then I'll summarize my results. So the first thing is to find the critical points. I get to use the product rule on this example. So I get 2e to the negative 1/4 x plus 2x times negative 1/4 e to the negative 1/4 x, using the chain rule to calculate the derivative of the second factor there. It looks like I can pull out an e to the negative 1/4 x and even a 2, leaving me behind a 1 minus 1/4 x. So to find the critical points, I'm going to set y prime equal to 0. And so what I find is, well, an exponential function is never 0. So I'm only worried about 1 minus 1/4 x equal to 0. 1 equals 1/4 x multiplied by 4. I get x equal 4. That's my only critical point in this problem. So my number line, all I'd have to do is plot 4. So I'm going to find test points now. I'll do 3 over here, 5 over here. Then I'll find the sign of the derivative. So f prime of 3 is going to be 2e to the negative 3/4 times 1 minus 3/4. This is positive, so the derivative is positive at 3, whereas at 5, I'm getting 2e to the negative 5/4 times 1 minus 5/4. This is positive, this is negative, which makes that negative. So then I've got the behavior of f. If the derivative is positive, that function is increasing. If the derivative is negative, that function is decreasing. And so I'm able to summarize down here. F is increasing for all numbers below 4. F is decreasing for numbers bigger than 4. F of 4, which in this case is going to be 8e to the negative 1, I believe, is going to be our local what? Well, what is it a local of? So, well, I went from increasing to decreasing here, and so that means that this is going to be a local max. We'll continue with a couple more examples in our next video.